Hello everyone. On this video, we will discuss the last problem in the network model, which is the shortest distance problem or the shortest route problem. And the algorithm that we will apply in order to find a shortest path in a network uh, is the Dijkstra's algorithm. It is a simple algorithm that we can use in order to find the shortest distance in a network. So here we have a network, and in this network, what we want to do is uh, we want we want to find a shortest route or distance from node 1 to node 6. Okay, that's what we want to do. And the number along the arc is the distance. So we have number 3 over here. That is the distance between node number 1 and node number 2. And another example, we have number 9 over here. That means the distance between node number 2 and node number 6. Okay. Okay, and we're gonna label the total distance as the capital L. Okay, so we're gonna label the total distance as the capital L. Since we start from node number 1, okay, so from node number 1 we can go to node number 2, we can go to node number 3, and we can go to node number 4. Okay, so that's the direct way that we can go from node number 1. We cannot go to node number 5 directly from node number 1. Okay, so I'm gonna put L as the distance, and I'm gonna have L in parentheses. So we start from node number 1, so the distance from node number 1 to node number 1 is 0, and the distance from node number 1 to node number 2 is 3. The distance from node number 1 to node number 3 is 7, and the distance from node number 1 to node number 4 is 4. Since we cannot go directly from node number 1 to node number 6 and to node number 5, so the distance, we put the distance as the infinity. So we put infinity. Okay, so we put INF, that means infinity. So the distance is infinite. Okay, so the 0 here, 0, it is for node number 1, sorry, 0 is for node number 1, 3 is for node number 2, 7 for number 3, 4 for number 4, this is for 5, and this one is for node number 6. Okay, so remember, the number that we have inside the parenthesis is the distance, and the number over here on the top is the label for the node. Okay, okay, from node number 1 we can go to node number 2. So we start from node number 1. We always start from node number 1, and then we gonna put what, star. So we label number 1, so that's mean we label node number 1, we put star. Okay, we put star here for node number 1, so that's mean we label that node number 1. So 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 we have a label star for node number one. So from the node having a label, we can go to other node. Okay. So from node number one, we have a label now. So from node number one, we can go to node number two, we can go to node number three, and we can go to node number four. Okay. So what is the distance? So the S, which is the, let's say that it is S, it is the minimum distance if we start from node number one. So from 1 to 2, the distance is 3. From 1 to 3, the distance is 7. And from 1 to 4, the distance is 4. Okay. And the minimum distance is 3. Okay. And 3 means go to node, to node 2 from 1. Okay. So we go from node 2 from node number 1. Okay. So what is the distance? The distance is 3. So the 3 means 0 plus 3. So that is 3. So the distance is actually it is 0 plus 3, but I do not put the 0 plus here. I just go directly with 3, 7, and 4. So it should be 0 plus 3, 0 plus 7, and 0 plus 4. And the minimum is 3. So from node number 1, I go to node number 2. So now I put star here in 3 because the distance is 3, and that is for node number 2. So I have two node with a label right now, node number 1 and node number 2. Okay. So from node number 1 and from node number 2, we can go to node number 3, we can go to node number 6, and we can go to node number 4 directly. Okay. I repeat, from node number 1 and number 2, we can go to node number 6, we can go to node number 3, and we can go to node number 4. Okay. Now let's do one by one. Okay. To node 3. Okay. To node number 3, we can go from node number 2. Okay, from node number 2 and from node number 1, and the distance is should be as mean what? Means 0 here from node number 1, 0 plus 7. And then if we go from node number 2, here we have 3, so 3 plus 2, and that is 5. Okay. So the shortest distance is 5. So that means we go to 3 from 2. Okay. So that's to go from node number 2 and number 3. And then we can also go to node number 4. Okay. And what is the shortest distance? The distance, what was the distance? Oh, sorry. To node 4. Okay. Go to node number 4. I think I still need the network. Okay, what is the S? S should be mean. Okay. So from to node number 4, we can go only from node number 1. Okay, so here 0 for node number 1, 0 plus 4, and that is equal 4. Okay. And the last thing, to node 6. Okay. And to go to knot 6, we can only go from knot number 2. Okay, and that means, okay, let me see. So here the distance is 9. Okay, okay, so this means S equal, okay, to knot number 6. So we can only go from knot number 2, and I still remember, so from knot number 2 we have 3 over here, so 3 plus 9, so means minimum of 3 plus 9, and that is 12, and that is the only one. Oh, sorry, I forget to put the minimum. Okay, so okay, I forget to put the minimum here, so it should be minimum of 3 plus 9. It is the only one, and therefore it is 12. Okay, so that's it. So we have here, we have 5, 4 and 12, and the minimum, let's say that it is S prime, is the minimum between 5, 4 and 12, and that is 4. Okay, and where is that 4? Okay, so that's mean we go from knot number 1 to knot number 4. Okay, so because here is the 4 as the minimum, and that 4 coming from here, so we go from knot number 1 to knot number 4. So what we're gonna do, we label knot number 4, and the distance is 4, and here it is. Okay, oops, sorry for that. So I'm just gonna put here. Okay, so to make it easy, I will also put label here. We have label for 1, we have label for 2, we have label for 4. Okay, so we will always need the network, so I'm gonna copy it down. Okay, we'll copy it down here. Okay, this is the network, and also I'm gonna need this. Okay, I'm gonna need that also, I think. Okay, now we already have label for knot 1, 2 and 4. Now we're gonna continue from knot 1, 2 and 4. We can go to knot number 3, number 5 and number 6. So we can go to 3, 5 and 6. Okay, I'm gonna need room over here. Okay, so now to knot 3, the first one, going to knot 3, going to knot 3. If we go to knot 3, so S will be the minimum of what? To knot 3, we can go from knot 1, knot 2 and knot 4. If we go to from knot 1, it will be 0, 0 plus 7, that is 7. If we go from knot 2, 3 over here, so 3 plus 2. And if we go from knot 4, we have 4 over here, 4 plus 1. 4 plus 1, and That means uh, what is it? 7, 5, and 5, and that's 5. Okay, so we can go to node 3 from node number 2 or from node number 4, and distance is the same, and the distance is the same, 5 and 5. Okay, that's from, let's go to node 3 now. How if we go to node node 3, node 5 now? So what is the distance if we go to node 5? So I'm just gonna put it here as equal minimum. So if we go to node 5, we can go from node number 4 only. Okay, so from node number 4, it is 4 right now here with the label, and the distance is 3, and therefore it is 7. Okay, this is to node number this is to node number 5. Now how if we want to go to node number 6? If we want to go to number 6, so we can go to node number 6 only from node number 2. Okay, so among the node with labels, among the nodes with label, we can only go to node number 6 from node number 2. So here node number 2, the value of 3, so 3, sorry, it should be the minimum of 2, that is 3 here, and plus the distance, which is 9, and that is equal 12. Okay, and next we need to compute S prime. S prime is the minimum of 5, 7, and 12, and that is equal to 5. So this means we go to node 5. So this means go to 5. We go to 5 from, let me see, we can go from we can go to 3. We can go to 3 from 2 or from 4. Okay, so we can go to 3 from 2 or 4, but here I'm just gonna select let me see, we can go from 3, right? Okay, so let me see here, 5, 7, and 12, and it is 5. We can go to node 3 with a distance of 5. We can go from 2 or from 4. Okay, from 2 or 4. So here it is the minimum 5, and that is, we are going to node number 3, and we're gonna put 3, we're gonna label 3 as permanent. Okay, and we're gonna update our L. So I think I'm gonna need more space. Okay, let me see what I can do. So what is our new L right now? So we update our L equal, we have 0, and then 3, and remember, here we conclude that we're gonna go to 3 and the distance is 5, so we put 3 as permanent, but it is not 7 anymore. The distance now is 5, and this is already permanent, 4, and then infinity, and then infinity. Okay, oh, it going down. So here node number 1 is permanent, number 2 is permanent, number 5 is number 3 is permanent, and here this guy also permanent. Okay, now let's see. In our calculation, we say that we can go to 5 and to 6, right? So here we for the permanent node is not number 3, because it is the value of s prime, the minimum of the minimum. But for node number 5 and 6, let's see, go to node number 5. Here the value of the minimum is 7, so now we can go there. So we put infinity when we can go there directly, when we cannot go there directly, but now we can go there directly from node number 2 and from node number 4. They are all permanent node right now, so we can remove this infinity. Okay, and remove this infinity, and here we're gonna have, let me see, 7, and here we're gonna have 12. So they have number, but they are not permanent right now. Okay, and here I think I make a mistake over here. Here we can go to node number 6, but it is not permanent. The distance is 12, so it is not permanent. It is not infinity right now, but it should be 12. Sorry for that. Okay, because we can go there directly from node number 2, and node number 2 is a permanent node. Okay, now what we need to do next, we just need to continue. We need to start from permanent node and go to the other node, to the non-permanent node. Okay, I'm gonna copy the, oh sorry, what is it here? I'm just gonna copy the network. Here it is. Okay, so from the permanent node number 1, number 2, number 3, and number 5, 1 2 3 4, sorry, from 1 2 3 4, we can go to node number 5 and number 6 directly. Okay, so we can go to 5 and 6. Okay, now going to go to 5, go to 5. So s will be the minimum of, so go to 5. Okay, we can go to 5 from 4 and from 3. Okay, yeah, we can go from 4 and from 3. From 4 the distance is 4, from 3 the distance is 3, but 3 here 5, right? So 5 plus 3, and from 4 the distance is 3, but from 4 the distance, we have 4 over here, so 4 plus 3, and that is 7. Okay, and then we're gonna continue, go to 6. Okay, so s will be minimum of, let's see, we can go from 2 and from 3. From 2 the distance is 9, and 2 here we have 3, so 3 plus 9, and from 3 the distance is 6, and 3 here we have 5, so 5 plus 6, and therefore we have 11. Okay, and then we calculate the s prime. S prime is the minimum between 7,5 and that is equal 7. Okay, so 7 we go to node number 5, right? So we put node number 5 as permanent, and the distance is 7. Here it's already 7, right? So we just need to, we don't no need to change this, because 7 and 7 it is the same. But here we have 11 going to node 6, but now we have 12, so we need to change 12 with 11, but it is not permanent. But here it will be permanent. So I'm just gonna copy this guy. Okay, I'm gonna put it here. Okay, so it stays 7, and but now it is permanent, but because node number 5 give you the minimum distance, but this guy you need to change it into 11, because here it is the 11 now. Okay, now so we have the only node that we can go now is node number 6. Let's go. Okay, so go to node 6. Okay, we can go to node 6 from 5, from 2, from 3, and from 5. Okay, so S gonna be minimum of, if we go from 2, so here we have 3 plus the distance is 9. Okay, if we go from 3, here we have 6, and the distance is 5 plus 6. And if we go from 5, here we have 3, 1 2 3 4 5, and it is 7. So 7 plus 3, and that is 12, 11, and 10, and that is 10. Okay, so what is the S prime? 10 is the only one. It is the minimum of 10, and that is 10. So we go to node 6. So node number 6 we label is as permanent node. But here, going to node 6, it is 10 right now, but here it is 11, so you need to update your total distance, or the L. Okay, okay, so here we have, should have here 10. Okay, oops, sorry. Okay, and we label that as permanent. Okay, now here we stop. We label all the, so we stop, we label all nodes with star. Okay, okay, so now the last thing that we need to do is to determine the route. So we are not done yet, because we need to determine the distance or the route. I think I need more space. Okay, let me see. Oh, sorry, I need more space. Okay, let me see. What I'm gonna do is I'm gonna copy the network, because I'm gonna need it. Okay, okay, and I'm gonna need the L with all node with star. Okay, so from here we know that the shortest distance is 10, but we need to determine the path or the route. Okay, in order to determine the route, so we need to do it backward. Okay, so we're gonna start from node number 6. So we start from node number 6. Okay, so see, from node number 6, so we can go backward, I mean 6 to 5, 6 to 3, and 6 to 2. So 6 to 5, 6 to 5. Here we have 6, here this is 5. What is the distance? 10 minus 7. 10 minus 7, that is 3. And see, from the original network, the distance is 3, so it is yes. Okay, now from 6 to from 5 to 6 to 3, so this is 6, 10 minus 3, 1 2 3 5, and it is 5. See, what is the distance from 6 to 3? It is 6 over here, so 5 is not equal to 6, so it is a no. Okay, so now from 6 to 2. Okay, so here we have 10 minus 2, 3, and here we get 7, but the actual distance is 9, so it is not the same. 9, so no, here 9 the actual distance, but the calculation say it is 7. So what is the first path? So our first path is here. Okay, so from 5 to 6, so 6 to 5 backward, but forward it should be from 5 to 6. Now here we have 6 to 5, now we go to 5. Okay, we start from node 5. Okay, okay, from node 5, here 5, we can go to 3 or we can go to 4. So 5 to 4, what is the distance? This is 5 and this is 4. 7 minus 4, and that is 3. What is the actual distance from 5 to 4? It is 3. It is the same, so it is a yes. And from 5 to C, 3. Okay, so 5, it is 7 minus 3, 1 2 3 5, and it is 2. What is the actual distance from 5 to 3? It is 3, so it is not the same. So it is 3, and it is a no. So what is the next thing that we need to do? So from 6 to 5, and then from 5 to 4. Okay, so I think I need more space. Okay, so here, so 6 to 5 and 5 to 4. Okay, here what we have right now. And now we go backward from 4. Okay, not 4. From node 4, we can go backward to 3, and we can go backward to 1. Okay, so 4 to 3. So what is the 1 2 3 4? It is 4, and 3, it is 5, and that is minus 1. So it is already clear that that is not it, and minus 1 is not the same as 1, so it is a no. And then from node, sorry, need to make it longer, from 4 to 1. So 1 2 3 4 4 minus 1 minus 0, this is for 1, so 0, and that is 4. And what is the distance from 4 to 1? And it is 4, and it is a yes. Okay, so now what we have is that from 6 to 5, 5 to 4, and 4 to 1. I think we are done. Okay, so what is the route? The route will be shortest route. I'm gonna put it, shortest route is 1. From 1 we go to 4, from 4 we go to 5, and from 1 to 4, 4 to 5, and from 5 we go to 6. And the total distance and L prime, yeah, the shortest distance, the optimal total distance, which is the minimum total distance, is 10. Okay, now let's check. Okay, 1 to 4, that is 4. 4 to 5, that is 3. And that means 7. And 5 to 6, that is 3. And 7 plus 3, and that is 10. Okay, so I think that is it, the shortest route problem. And this concludes our discussion on the network models. And on the next video, we will start a new chapter. Thank you.